Hi guys, I'm Jonah Nicpon, and this is my Physics 2 Lab 4 analysis. Nope. Which way? Okay, introduction. So the purpose of the lab was to model circuits and understand the relationship between voltage, current, and resistance. And what we did in the lab was that we used the online simulator to create a closed circuit and calculate the voltage at different points under different circumstances. And the physics ideas used are the current is equal to the voltage divided by the resistance. And then we also use that the delta V is equal to delta V naught times e to the negative t over RC. The preliminary results were that we got the total voltage around the entire circuit was equal to 0, and the discharge over time was negative 0.1667. Our assumptions were that the voltmeter has infinite resistance in the simulation and that the battery has no resistance in the simulation. So part 1 of the experiment, we just had the simple circuit, and we found that the current was 0.2041 amps, and this aligns with what we saw in the simulation, which said 0.02 amps. The effect of the effect of flipping the amplimeter was nothing. Part 2. In part 2, we used a voltmeter and found that the voltage at the start was 3, and this makes sense because it's just the two 1.5 batteries, so it's 1.5 volts plus 1.5 volts to equal that 3 volt. And then we found that the current on the ammeter after the voltage was had a value of 0 amps because the voltmeter has infinite resistance, causing no current to pass through it. So there's no current at the ammeter. In part 3, we summed up each of the parts of the current. So in AB, we had 3 volts. In CD, we had negative 9.45. And in EF, we had negative 2.055. And this adds up to 0. Which is what we expect because of the loop rule, which states that the difference in the potential difference will be 0. Our graph for the project looked like this. As you can see, there is from A to B, it increases, and there's the little break between A and B because this is the distance between the two batteries. And then we see that during C to D, that's the first resistor, and then from E to F is the second resistor, and then after that it's 0. Part 4 of the lab, we added another amplimeter and to see if to find the resistance there, and we found that it was 0.006, and this is because the current takes the path of least resistance, and because it's easier to pass through the amplimeter, which doesn't have any resistance, than the resistor, it passes through the amplimeter, and so it only goes through the 47 the resistor with 47. And our results were that the resistor had the first resistor was 47 ohms, the second resistor was 100 ohms, and the resistance of the wire and the ammeter was 0. And the 10 ohm light bulb had a 5-second charge, a 9.5 second discharge, and the 20 ohm light bulb had a 14-second charge and 20-second discharge. The discharging over time, we took negative 1 over RC, which was equal to negative 0.1667. We also took this, the discharge over time, taking the natural log of V divided by V naught over T, and we found the same value. So for the discussion, what if we used a real ammeter and how is it different? Real ammeters would not have infinite resistance like they did in the simulation. So the magnitude of voltage across the batteries would change due to the loop rule. And if we used a real batteries do have resistance and therefore would not occur instantly like the model. And it would take time to charge the capacitor with a real battery rather than instantly like the simulation. Thank you for watching.